Lesson 1-8, subtract unlike fractions. In this lesson, the term unlike refers to fractions where the denominators do not match, as in practice problem number 1, 1/2 minus 2/5. Before we begin working through that problem and identifying the common denominator and so on, take a look at this teaching note on the right. It says rewrite the difference, and difference here means subtraction, so that the fractions have the same denominator. You can use the product of the denominators 2 times 5 as the common denominator. Well, I don't like this particular method. I'm going to cross that out. Sometimes I see kids use that as a shortcut, and I don't think that's the right way to teach or practice the skill. To me, the right way to go about finding a common denominator is this. Step 1. Ask yourself this question. Will the larger denominator work? In other words, if you look at the two denominators that have been given to you, as in the case of practice problem number 1, 2 versus 5, the larger of those two denominators is the 5. Is 5 a multiple of 2? Can I take 2 and multiply by anything to get 5? The answer in this case is no. The larger denominator won't work. If it did, life would be good, because then we would use that as our common denominator and only need to change the other fraction or rewrite the other fraction as an equivalent with that denominator. But back to this problem. The first thing that we're checking, will the larger denominator work? The answer came up as no. So 5's out, but don't give up on 5, because next we're going to go through the multiples of this larger denominator until we find the first one that works. So I'm going to say list multiples of the larger denominator until you find one that is a multiple, or that works, as I like to say, for the other. So let's see this in action again for practice problem number 1. I take my larger of the two denominators, 5, and I start listing out my multiples. I'll do that over here. 5, 10, 15, 20, 25. Before I go too far, we already said that 5's out. 5's not a multiple for 2. But notice that its very next multiple, 10, does work. 10's an even number. 10 works for 2. If I wanted to, I could also list out my multiples for 2 and see, sure enough, 10 is the first multiple on that list that is also a match for this list, right? So 10's my common denominator. 10's also known as the LCM, or least common multiple, that 5 and 2 both share. Now we're rolling. We've got 10 as our common denominator. And in this case, the next set of steps have already been worked out for us here. So let me talk you through them. First, we're going to look at the fraction on the left, 1/2, and we're going to ask ourselves, 1/2 is equal to what over 10? What we do to the bottom, we do to the top when we rewrite fractions as equivalent fractions. So over here, 1 over 2 equals 5 over 10, because to start with a denominator of 2 and end up with the common denominator of 10, I needed to take the bottom and multiply it by 5. What I do to the bottom, I must do to the top. So my starting numerator of 1, I'm also going to multiply by 5 to get a new numerator of 5. 1/2 is equivalent to 5/10. The next fraction, 2/5. Likewise, we're going to rewrite that as something over 10. We start with a denominator of 5. Multiply that by 2 to get a common denominator of 10. What we do to the bottom, we must do to the top. We start with a numerator of 2. Multiply that by 2 to get a new numerator of 4 tenths. Now, we have rewritten the original problem, 1/2 minus 2/5, as 5 tenths minus 4 tenths. Now that we have rewritten this problem in a way where both fractions have the same denominator, we can perform the operation. We can subtract. When the denominators match, keep it the same, 10 stays a 10, and let the numerators do the work. 5 minus 4 equals 1. 1/10 is our final answer. Number 2. 3/4 minus 5/8. Here, the two denominators are the 4 and the 8. Will the larger denominator work? Is 8 a multiple of 4? It is. Ding, 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 ding. That means that 5/8 can stay the way it is because it already has 8 as its denominator. We need to rewrite 3/4. You can see the steps down here. We want to rewrite 3/4 as something over 8 because 8 is going to be our common denominator. To start with 4 and end up with 8, I need to multiply the denominator by 2. What I do to the bottom, I must do to the top. If I start with a numerator of 3, I need to multiply that by 2 to get 6. Therefore, 3/4 can be rewritten as 6/8. And now I can show the original problem, 3/4 minus 5/8, rewritten as 6/8 minus 5/8, and perform the subtraction to finish the job. 6 minus 5 for the numerator is 1. I get a final answer of 1/8. Number 3, 2/5 minus 1/6. Our denominators are the 5 and the 6. 6 is the larger of the two denominators. Ask yourself that question. Is 6 a multiple of 5? No. 6 is out. Go through your multiples of 6 until you find one that works for 5. 6, 12, 18, 24, 30. 30 was going to be our common denominator. I need to rewrite both fractions having a common denominator of 30. Two over 5, I'm going to rewrite as something over 30. 1/6, I'm going to rewrite as something over 30. What I do to the bottom, I must also do to the top. So in the case of 2/5, I need to multiply the denominator by 6. So I'll multiply the numerator by 6, and 2/5 is going to become 12/30. In the case of 1/6, and sorry for the blurriness there, in the case of 1/6, I'm going to multiply the denominator by 5, so I'll do the same to the numerator, and 1/6 is going to become 5/30. Now, the denominators match, so I can finish the job and perform the subtraction. 12 minus 5 is 7. The denominator remains at 30. I get an answer of 7/30. Practice problem number 4. 2/3 minus 1/6. Between the two original denominators, 6 is the larger, and 6 will work for 3. So in this case, I only need to rewrite 2/3. What I do to the bottom, I do to the top. If I start with 3 and I want to rewrite it as 6, I multiply the bottom by 2. Do the same to the top. So 2/3 gets rewritten as 4/6. We already said the 1/6 will remain unchanged because that has the common denominator that we wanted for this problem. We get an answer of 3/6, but notice that 3/6 can be simplified by dividing the top and bottom by 3. We can show a final answer of 1/2. "3/8 minus 3/10. The two denominators given are 8 and 10. 10 is the larger, but 10 is not a multiple of 8, so 10's out. Don't give up on 10. List out your multiples of 10. 10, 20, 30, 40. 40 is going to work as our common denominator. Rewrite both of these fractions so that they have a denominator of 40. Over here, for 3/8, multiply the bottom and top by 5. Over here, for 3/10, multiply the bottom and top by 4. (15/40 minus 12/40 gets us 3/40. As our final answer. Number 6, 1/2 minus 1/4. 4 is the larger of the two denominators, and 4 will work for 2. So I'm going to rewrite 1/2. Multiply the bottom and top by 2 to rewrite this as 2/4. 1/4 remains unchanged. 2/4 minus 1/4 is 1/4. I'll write it up here. 5/6 minus 7/12. 12 is the larger of the two denominators. 12 will work for 6. So I'm going to rewrite 5/6 by multiplying the bottom by 2 and the top by 2. 7/12 will remain unchanged. And I get an answer of 3/12. But notice that 3 and 12 both share a common factor of 3. So I can divide top and bottom by 3 to simplify this. And when I do, I get a final answer of 1/4. Finally, 4/5 minus 1/4. 5 is the larger of the two denominators, but 5 is not a multiple of 4, so 5's out. Go through your multiples of 5 until we find one that works for 4. 5, 10, 15, 20. 20 is going to be our common denominator. Let's rewrite 4/5 by multiplying the bottom and the top by 4, because 20 is the denominator we're going after. Let's rewrite 1/4 as by multiplying the bottom by 5 and the top by 5, and then 16 minus 5 is 9. The denominator remains at 20. We get a final answer of 9/20. If we go back to the original steps that I started to write at the top, when you look at a problem like this, whether you're adding or subtracting unlike fractions, first ask yourself, will the larger denominator work? If so, then life is good. You can use that as your common denominator, and you may only need to rewrite one of the two fractions as an equivalent fraction. But if not, then we go through the multiples of the larger denominator until we find one that works for the other. That's a multiple for the other. Then we rewrite one or both fractions with the common denominator. Once the denominators match, solve. I'll put a smiley face.